Alright guys, we're going to try this again because I went all the way through and didn't hit the record button. So these were a few examples on your quiz that you had some trouble with that I just want to try to clear up for you guys. And you noticed here, even on the first one as we redo this, I had to erase some things. That for the given function, identify the transformation. The one on your quiz was a little bit of a transformation here. It was negative 3 times 7 to the x. Okay, and this is asking you what's going on here. How does this really relate to the parent function? Now I've highlighted the parent function here, y equals ab to the x. Okay, so a couple things you can notice right off the bat is that your x value, there's nothing being subtracted from x or added to x. So what that tells me here, if this thing ever stops spinning wheel of death, is that there's not going to be any shift left or right because, well, I guess we'll keep using the spinning wheel of death here because this thing's probably going to crash. Oh, there we go. Yay. No. It took a while to think. There's nothing being added or subtracted to this x value right here. So there's no shift left or right. And if you think about the k value, if you're adding something or plus or minus here some value on the outside, then that would tell you there's a shift up or down. But neither one of them's there. So there's no shift left or right and there's no shift up and down. So you've got to concentrate on this value right here. Okay, your a value. Now this would be growth, okay, because b is greater than 1. B is 7 in this case. Okay. We're not asked that here, but if we look at the negative 3, there's two things that are happening. Number one, since this value is negative, you have a reflection over the x-axis. So you're going to have a reflection over the x-axis. Okay, that's number one. And then the second thing here is that your a value is 3. And that should be x-axis, not y. Sorry, x-axis there. And the second thing you have here is you're going to have a stretch by a factor of 3. Okay? Because your a value is greater than 1. So stretch by a factor of 3. Sorry, my computer's a little bit slower than what I'm writing, so I can lose a little bit. All right, so let's go on to the next example. And this one has to deal with money, and specifically depositing money. So, like I said, I went through once before and I screwed this up, and I didn't record. So it says, suppose you deposit $1,500, and I highlighted that, in a savings account that pays an interest at an annual rate of 5%, and that's really important too. If no money is withdrawn from the account, answer the following questions. So there was two formulas we used. One, we're going to use in this case, it's going to be y equals, okay, the principal times 1 plus your rate. Now, the 1 plus r is your b value, so that's either going to be growth or decay. In this case, since you're depositing in a bank, you better have growth. Okay, so this is when we have compounding annual rate of return. Your rate is at a decimal. So if we want to know how much money we're going to have after 4 years, we can set up the problem like this. Your P is your principal rate, your starting amount. So I initially deposited $1,500. Okay, now my rate's going to be 1 plus, or my B value is going to be 1 plus your rate, which is 0.05 as a decimal. And so my B value is 1.05, and it should be growth, okay, because I'm putting money into an account. 4 years later, that's our time. Okay, so there's our setup. And if you plug this in your graphing calculator, I get about $1,823 and 26 cents when I round. Okay, so that's about how much I'm going to have after 4 years. After 17 years, it's the same format. You're going to have the $1,500. That's your initial amount. And you're going to have 1.05. That's not going to change. Your rate's not changing. It's locked in. The only thing that changes here is our T value. So hopefully you would know that you have more in the account. So we do. We have $3,438.03. Okay? So that's how much after 17 years. Now the trick, they change this up a little bit on part C, and they say, well, how long is it going to take us to get $2,000? So that's an interesting way to look and say, well, this is how much I have after 10 years. Well, how much am I, if you want to buy a car or something or pay for college, you might say, well, how long will it take me to get $40,000 or $50,000? Just by sticking that money in there and never touching it again. When will it get to 50,000? So you can see that in this case we want to know how long will it take us to get to 2,000. So you use the same equation, but instead of not having your y value, you have y. And this time you're looking for t. And so we do have 1,500. So most of the right side is going to stay the same, the 1.05, the principal. But the only thing that's different is this t value. We don't know it. Okay, so you got to solve this equation. So you're going to divide each side by 1,500 first. Okay, so get rid of that value, and you get about 1.3 repeating when you divide that out. So I'll just round 1.33. Okay, and that equals the rate, or the growth factor, right? Whoops. So now, a lot of people will say, let's divide by 1.05, but you can't, because that's being raised to the t power. So we have to be a little bit tricky and clever. We've got to multiply each side by the natural log. And when I do that, by taking the natural log of both sides, by using properties of logarithms, I can bring out the t. The t can go out front. And so I know that when I solve for t now, I divide each side by natural log of 1.05. So I have the natural log of 1.33 over the natural log of 1.05. And you end up with 5.84 years. I think I rounded down here. Or maybe I rounded up, I wasn't sure. So now if they say round to the nearest year, you'd say, in this case, you would say it takes 6 years. Now what happened on the quiz is that this answer may be 5.1, and then everybody was rounding down and saying, oh, it takes 5 years. Well, if it takes 5.25 years, you can't round down to 5, because then you wouldn't be at 2,000. You actually have to round up to 6 years, then you would ensure the fact that, yes, you would have $2,000. Okay? So the final example here is just identifying that growth or decay, and a lot of us missed that on the last one, if this page is about in the beginning. Okay, this is decay, and the decay factor, okay, is 0.68, okay? And your A value, the y-intercept here, is what your A value is. So a lot of people get this wrong because they look at A and think that's the growth or decay factor. It's not. It's the base being raised to the power. So if you guys have any questions or comments on this, let me know in class, or you can email me, and we'll see you next time, okay? And it's still recording.